everyone, I'm so glad that you joined us once again. Today we're going to be looking at calculus and we're going to be looking at cubic functions. Today we're going to look at interpreting cubic functions and also look at finding the equations of cubic functions. So let's get started. Remember, calculus is a huge section, 25% of your final exam, and of that, cubic functions take up the most amount of marks. So today, by the end of today's lesson, we are going to look at finding the equation of cubic functions from given information. The information can change, so there's no one method that always is going to work. Often learners want to know, which method do I use to answer this question? Well, it changes depending on what given information you have. So the questions change depending on the given information. And so we've got to practice a lot of questions to see how these questions can be asked. We're going to look at interpreting cubic functions correctly and including key points and understanding their significance. Some of the main words that we see when we talk about cubic functions: stationary points. Remember, stationary point, that's where your first derivative is equal to 0. Another word for stationary point is a turning point. Your intercepts, that's where the graph crosses either the x or the y axis. A point of inflection is a point where the curvature of the graph changes. It's either going to go from concave up to concave down or vice versa. And importantly, we find the point of inflection by setting the second derivative equal to 0. And it's really what the concavity tells us is it describes whether the graph is going to be concave up or going to be concave down. So it's all assisting with the shape of the graph. Some of the common errors that we see with cubic functions, especially when we're looking at interpreting, like I said before, there's no one method. So sometimes learners get a bit stuck because they use the incorrect method for finding the equation when they haven't even been given that information. So they might say, well, I know it's calculus, I'm supposed to derive. And then you just derive, even though the question doesn't require it, okay? So you need to take care and make note of what information you've been given. So errors in interpretation also creep in. What has the question given you and what do you do with that information? So today we're really looking at improving your ability to do well in an exam and to pass really, really well. So here we're thinking about things like how do you manage your time, and I'll give you some tips along the way of how you can include active learning methods in your practice leading up to the exam and leading up to preparing to really ace your exam to the best of your ability. All right, guys, we're going to take a quick break. We'll be back after this. Welcome back, everyone. We are continuing our discussion about cubic functions, and specifically we're looking at interpreting cubic functions and finding the equation. So some places where you may encounter problems in cubic functions is confusing the intercepts with the stationary points. Remember, stationary point is distinct from an intercept. An intercept is where the graph cuts the axes. Stationary point is where your derivative is equal to 0. Concavity is a big thing. A lot of learners get confused about interpreting the concavity, and we'll go into more on that as we go through our questions. It's very important to spend time analyzing the cubic function and really seeing what information they have given you. And this is critical when it comes to interpreting cubic functions. You have to let the information they give you guide your steps, all right? There's no one method that works for everything. These concepts that you've learned in grade 10 and 11 really help you in grade 12 with your cubic functions, and that's plotting points and also really understanding how to find the equation of a quadratic function. We don't use the same formula or the same method, but it helps you in your understanding and the logical way we approach finding the equation of a cubic function. Okay, let's go back. So let's start with our first example. So here we are given the graph of h of x, and we are told that the graph has a turning point at 0, 0. This is drawn on the graph, and b, 4 and 32. They tell you that a is an intercept of h. It's an x-intercept. So we note that all the given information is actually written on the graph. We take a note of this information and we see how it can be helped to find out the equation of the graph, because we can see that we have unknown variables a and b. So at some point the question is going to ask us to find the equation of this graph, so find the values of a and b. We've got the turning point. Remember, the turning point is also a point that lies on the graph. So we are very likely going to rely on point B quite heavily, because if you look at the other turning point, it's at the origin where the coordinates are 0, 0. And substituting 0, 0 into this equation is going to take you nowhere, because everything is just going to cancel out to 0. So we suspect already that we're going to rely heavily on the coordinates of B. Okay, let's have a look at what the first question says. It says, as we expected, show that a is equal to something and b is equal to something. So a must be -1, b is equal to 6. We can see from the shape of our graph, we do have a value of a that has to be negative. Right, so how do we go about that? Remember what I said to you is that we are likely going to rely on the coordinates of b. We've got the equation given to us as ax cubed plus bx squared. Okay. So how do we use the coordinates of B? We need to remember that B is not only a turning point, it's also a point that lies on the graph. So it gives us two bits of information. It's a stationary point. So therefore, the derivative at the point B is 0. It's also a point on the graph. So we're going to use that information to help us formulate equations. So I know that h of 4 is equal to 32 because that's what the question told me. And if I simplify that a little bit more, I get 64a plus 16b is equal to 32. And what I can do then is divide through by my common factor, by a common factor of 16. So we end up with 4a plus b is equal to 2. All right. And then all I've done here to get to equation 1 is I've rewritten this. So I can already tell that I'm going to be using simultaneous equations. Simultaneous equations, guys, remember you do a lot of simultaneous equations back in grade 10, where you've got two unknown values. You don't know, for example, a and b, and you've got to use information to get two equations that can help you solve simultaneously. So my one equation, by making b the subject of the formula, is 2 minus 4a. All right, where do we get the next equation from? So that comes from, and let's just take our writing out here because it's taking that away. That comes from the fact that we've got information about the derivative. We know that at the point 4, our graph turns. So that means that the value at the point 4, h dash of 4, is going to be 0. So I substitute 4 in place of x, and I end up with 16 times 3a plus 2b plus 4 is equal to 0. How does this help me? Well, this is going to help me to get my next equation. Simplifying, I get 48a plus 8b is equal to 0. And therefore, we can call this one equation 2. You can go further there if you really wanted to, and you can get into fractionals equations, but you really don't want to tackle fractions if you don't have to in a simultaneous equation. Things can get messy. Okay, so we've got our two equations. We now need to solve them. So our first equation, b is equal to 2 minus 4a. Our second equation is 48a plus 8b is equal to 0. We've got a guide. We know we've got to show that a is -1 and 6. This is excellent when they give us this information, because I know already that if I don't get to these answers, then my answer is, I've made a mistake somewhere and I need to go back and check. My answer is incorrect. Okay. So I'm going to say substitute equation 1 into equation 2. So in place of b, I'm going to place 2 minus 4a. So I'll have 48a plus 8 into 2 minus 4a is equal to 0. So therefore I get 48a plus 16 minus 32a is equal to 0. 48 minus 32, that's going to give me 16. 16a is equal to, take this constant over to the right hand side and divide through by the value of 16, and I will get that a is equal to -1. And at this point, we get really happy because we know that we haven't made any careless errors, okay? We've got the value of a. We need to find the value of b. So what do? We take this value of a and we substitute it back into equation 1. So b, and if obviously we do everything correctly, then we know that we're going to get an answer of 6. Okay, so it's 2 minus times a minus is a plus, 2 plus 4 is 6. Okay, so this makes us happy because we've answered the first question correctly on interpreting graphs, right? We've got full marks here, we've got the value of a, we've got the value of b. In a question like this, you know straight away if you're right or you're wrong because they give you the answer basically in the way that they've phrased the question. Okay. So now that we've got the values of a and b, we can get on some more information about the graph. They want us to find the coordinates of a. So we look at the graph, we look at a, and we say to ourselves, but what is a in relation to the graph? And you can see that a is a point where the graph cuts the x-axis, so this is called an x-intercept. Okay. And as soon as learners hear, well, it's cubic graphs and it's intercepts, straight away they want to go to factor theorem. But don't let that be your first call always, because you need to analyze what you've been given. In this question, I don't need to go to factor theorem because I can see that there's a common factor which I can take out of x squared. All right. So, in fact, let's take out negative x squared. And we'll end up with x minus 6 is equal to 0. So therefore, from our first factor, we get that x is equal to 0 or x is equal to 6. Again, we know that we're right because, in fact, 0 was one of the x-intercepts. We were given that. So therefore, the value at point A is 6. But we are not done because, yes, x is equal to 6, but they asked us to write this as a coordinate, which means we need an x and a y value. So therefore, x is 6 and y is 0. Okay. Now we're going to go on to finding the values of x for when h is increasing. Increasing, remember, what does increasing mean? Increasing means that as your x values increase, your y values increase at the same time. So the graph is sort of going upwards, okay? So write in the values of x for when h is increasing. We have to analyze sections of the graph. If I look when x is less than 0, so to the left of this point, at this point I can see that y value is much bigger than this 0 here. So therefore at this point my graph is decreasing. As the x values are increasing, your y values are getting smaller. That's not going to work. If I look between 0 and 4, right? What do we see there? Between the x values of the turning points, we can see that as the x values increase, the y values also increase. So therefore, for the first part, our answer is between 4 and 0. And if you look at the last portion, for x greater than 4, you will see that your y value there is much bigger than the y value there. So at this portion, your graph is doing that. It's decreasing. So that's not a solution that we are interested in. Okay. Part 2 of this is, where is the graph concave down? For what values of x? Where is the graph concave down? So learners often struggle to understand, what does concave down mean? Think of a concave down, it's like a cup. If you turn it upside down, everything's going to fall out, right? So that's concave down. It's talking about the curvature of the graph. Where is the graph concave down? So I can see that my point of inflection is perhaps somewhere there, and the concavity changes at our point of inflection. So I can see that it's about somewhere there, but what is that point there? Where is the graph concave down? So the graph is concave down when your second derivative is negative. Okay, so let's just go back to finding what was our equation again. So it's minus x cubed plus 6x squared. So it's where h of x, which is equal to minus x cubed plus 6x squared. It's where the second derivative is negative. That's where my graph will be concave down. So we find the first derivative. We get minus 3x squared plus 6. And then we take the derivative of that to work out the second derivative. So we get minus 6x plus 6. And we're looking for where this guy is negative. So therefore we do a quick inequality. It's where minus 6x plus 6, in fact we're running out of space, so let's just neaten this up a little bit. We're looking for where minus 6x plus 6 is less than 0. So we get it's where minus 6x is less than minus 6. Remember, when you divide an inequality by a negative, you must change the sign. So if we do that, we get it's where x is greater than 1. So for all values where x is greater than 1, we have a graph that is concave down. All right, so with that information, let's take a quick break and we're back after this. Hello everyone, welcome back. We are continuing our discussion on cubic functions and we're looking at graph interpretation. So in our next example, our sketch is given and we are told that this is the sketch of f of x is x cubed plus bx squared plus cx plus d. With that information, I want to see what is the best way I can interpret what I've been given to answer the questions that come. So let's continue reading though. The solutions of the equation f of x equals to 0. F of x is equal to 0 is your x-intercept. So they tell us that's minus 2, 1, and 4. So they've actually given you a lot of information. They've told you your cuts here on the x-axis are minus 2, 1, and 4. Okay. I'll also note at this point that the coefficient of x cubed, a, is 1. So you see that a is not an unknown value. It's only b, c, and d that are unknown values. Let's see what the question requires. So the first one says, calculate the values of b, c, and d. Okay, so how do we calculate the values of b, c, and d? We know that our equation is x cubed plus bx squared plus cx plus d, and we've got all that information about the x-intercept. Remember, we were given these values here. So now at this point, learners look at this and they've got 3 bits of information and they've got 3 unknowns and they think, oh, well, let's go into simultaneous equations. That's going to be a very, very long process and a long-winded way to get to the final values of B, C, and D. This is why analyzing what you've been given is so important. You've been given the roots of the equation. So in other words, you've been given the equation of the cubic function in factorized form. Okay, let's see how you've been given that. We know that minus 2, 1, and 4 are our roots. So therefore, x plus 2 was a factor of this graph, x minus 1 was a factor of this graph, and x minus 4 was a factor of this graph. So therefore, if I want to find the values of b, c, and d, it simply just requires me to expand these brackets. When I expand these brackets, I'll be able to calculate the values of B, C, and D. So let's multiply them out and let's see what we get. We've got x plus 2 times, if you times the last 2 brackets together, we get x squared minus 5x plus 4. And then we multiply the x plus 2 through that equation and we end up with x cubed minus 3x squared minus 6x plus 8. We don't stop there because we need to say, therefore, B is equal to, and we include the sign. If you don't include the sign, you will get this marked as incorrect. B is negative 3. We need the number with the coefficient with its sign. C is equal to negative 6 and D is equal to 8. Positive 8, the positive sign is implied even if we don't put it in there. All right. Okay, let's have a look at part B. We now need to find the x-coordinate of B, which is the turning point of F. So now you start thinking, when we start talking about turning points, what do we need? We need the derivative. That's right. Okay, so information about maximum, minimums, and turning points all means that we need to work out the derivative. We've got f of x is equal to x cubed minus 3x squared minus 6x plus 8. We've worked these values out, so therefore we simply derive to get 3x squared minus 6x minus 6 is equal to 0. Let's divide through by, remember we make the derivative equal to 0 because at the stationary point the gradient of any line passing through that point would be 0. Dividing through by 3, I get x squared minus 2x minus 2 is equal to 0. Now we get to this point. Okay, I've written all over that solution, not a problem. Let's see what happens here. Okay, we now get to this point where we've got our equation in this form, and we look at this and we say, well, what do? I cannot factorize that in the traditional sense. So this is when we rely on something we learned in grade 11 called the quadratic formula. When I cannot factorize equations, I use this formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. We substitute our values for a as 1, b is equal to minus 2, and c is equal to minus 2 into this equation, and we will then get that x is equal to either 1 plus the square root of 3 or 1 minus the square root of 3. We look at the position of b and we see that it's on the negative side of the y-axis. So therefore we say that that value must be, and all they're looking for is the x-coordinate, that value must be 1 minus the square root of 3. If you go on to write this in decimal form, it's not a problem, but it's not completely necessary. Okay. All right, guys, and now for the last part of this question, it says determine the equation of the tangent to the graph at x is equal to minus 1. So wherever minus 1 is, we want to find the equation of the tangent. So if we're looking for the equation of the tangent, we remember that y is equal to mx plus c. That's the equation formula that we're heading towards finding. We need the gradient, we need the y-intercept. This is at the point x is equal to negative 1. So we've got f of x, that's our equation now, and we want to find the gradient at the point minus 1. So what we need to do is we take the derivative. So we get 3x squared minus 6x minus 6. We know that the x value is minus 1. So at the point where the tangent touches the graph, they have the same gradient. So I substitute minus 1 in. And we get, what is this? 3 plus 6 minus 6. Those two cancel. So therefore, I end up with 3. So therefore, the gradient, m, is 3. I need to work out the y-intercept, but to do that, I also need to work out what the function value is at the point minus 1. So I need to take that minus 1. So we've got m is equal to 3. To find the coordinates, we take the minus 1 and we substitute it back into our equation. So we end up with, let's quickly do this on our calculator. We've got minus 1 that we're substituting for x. Our first term would be minus 1 minus 3, because 1 squared is just positive 1, plus 6 plus 8, and we end up with 10. So therefore, the y value at this point of contact is 10. To find the equation, we use y is equal to mx plus c. We still need the y-intercept. So we say y is equal to 3x plus c. And we substitute x is minus 1, y is 10. So we get 10 is equal to 3 times minus 1 is negative 3 plus 7. So therefore, 10 plus 3 is equal to 13. C is 13. So therefore, my equation is y is equal to 3x plus 13. Okay. So we've got here the graph of gx, which is drawn, and you see that there are a few unknown values here. We've got ax cubed plus bx squared plus cx, a, b, and c, of course, being the unknown values. It's a cubic function. We can see that. It's got 2 turning points. And we can see that it passes through the point 0, 0. That's our y-intercept. They've given us the x-coordinates of the turning points are minus 1 and 2. All right, so we look at all of this information. We take in what have we been given. And now we're going to look at what have we been asked. Everything that they've given you so far is on the graph. So the first question says, if the derivative is minus 6x squared plus 6x plus 12, find the equation of g. So you've been given the graph of the derivative. You haven't been given the graph of g of x. So therefore, they've already taken the derivative and they've given that to you in simplified form. You now need to use that information to help you find a, b, and c. So there's no one method to always find the equation of a cubic function. It changes depending on the information that they've given you. This one is slightly different. Because they've given you the graph of the derivative, we have to handle things a little bit differently here. We know that a, b, and c are our unknown values, okay? And we're trying to find, they've given us that g dash x is minus 6x squared plus 6x plus 12. Now, I know that if I were to find the derivative function myself, even though I don't know a, b, and c, I would need to use the power rule. 3 times a would be 3a. Subtract 1 from the power, so I get 3ax squared. Plus the derivative of bx squared, multiply 2 by b, so it's 2 times b, x to the power of 1. 2 minus 1 is 1, plus c. X to the power of 1, we multiply c times 1 and subtract 1 from the power, so we just end up with c at the end. And now look at this, and I compare it to what they've given me. They've said, well, this is supposed to be minus 6x squared. This is supposed to be positive 6x. And this last one is supposed to be positive 12. So straight away I compare and I can see, well, that tells me that c has to be 12 if these are equivalent expressions. So c is equal to 12. I know that this entire coefficient must have the same value as minus 6. So therefore I equate 3a to negative 6, and I solve for a by dividing through by 3. So I get a is equal to negative 2. And then finally, to find b, we do the same thing. 2 times b, that coefficient, needs to be equal to positive 6. Remember, we include the signs. So therefore, dividing both sides by 2, I get that b is equal to 3. So now my equation, I've got a, b, and c. I've answered the question. Let's write down what is our equation going to look like now. We're going to have y is equal to negative 2x cubed plus 3x squared plus 12. Okay, and if you quickly want to check if it's correct, you can plus 12, that's right, yes. Okay, you can quickly take the derivative to c. I have missed out an x value, sorry, cx is equal to 12, so c is equal to 12, this should be 12x. So you can quickly take the derivative to see that your answer matches what you were given. If I take the derivative of this expression, I get minus 6x squared plus 6x plus 12. And this is indeed what they gave you. So therefore you know that you have found the correct expression for g of x. All right. Okay, everyone, let's move on to the next question. So here we've been given the graph of h of x. We can see that the coefficient of this graph of a is negative 1. So we can see that this graph has a minimum turning point and a minimum first and then followed by a maximum turning point. Okay, we can see that the values a, b, and c are equal, well, are unknown. So at some point we may need to find those. The coefficient of x cubed is negative 1. In this case, it's not going to be called a because they've moved a over there, which is absolutely fine. Nothing wrong with that at all. We've got that a and b are your turning points. B has the coordinates 6 and 0. Let's fill in our information on the graph. And these are the turning points. We've got the point T, 3, and Y. The graph of H passes through the origin, so therefore we know straight away without doing any working that this value C must be 0. How do I know that? Because you can see that this graph is going through the origin, so therefore the y-intercept is 0. So straight away I can already make an alteration to my equation and say it's h of x is equal to negative x cubed plus ax squared plus bx. C is 0. All right? The question says, show that A is equal to 12 and B is equal to negative 36. Okay, so we've got so far in our question, we've got that we have h of x from the previous slide. Let's just take that information down, is equal to negative x cubed plus ax squared plus bx plus ax squared plus bx. C, we already saw that the value of that was 0. We need to find A and B based on what information we've got. What's really nice when they give you a question like that is they tell you the answer, so you know what you're working towards, and that helps you to guide your final solution, because if you know you get an answer for A that's not 12, you need to go back and check. If you get an answer for B that's not negative 36, we need to go back and check. Remember, the key bit of information they've given us here is that this value at B, that x-intercept, was 6 and 0. Okay, so we're going to use that bit of information to inform us and help us to make our decisions about solving for A and B. So we see that this is a turning point and it's also a point on the graph. This means it will help me towards finding an equation which I can solve simultaneously to find the values of A and B. So I know that h of 6 is equal to 0. Substituting that value of 6 in, I will get, so we're substituting 6 in here, we're going to get minus 6 cubed plus A times 6 squared plus B times 6. All right. Simplifying that, 6 cubed, that is 216, but let's just check if we are correct there. 6 cubed, it's 216, so we end up with negative 216 plus 36a plus 6b is equal to 0. So we can then rewrite, and we're just going to need to rewrite this expression here, 6b, and we've got 36a is equal to, remember we had here minus 216, so if I take that over to the right hand side, it's going to become positive 216. You can divide through by a common factor, and let's see what we get. We get b plus 36 divided by 6 gives me 6a is equal to, and let's double check, 216 divided by 6 is going to be 36. Okay, we can rewrite this expression as b is equal to 36 minus 6a, when we call that equation 1. Now we need another expression which we can use to solve simultaneously with this equation. So we've got our equation 1, we need our equation 2. So that comes from the fact that this point B is also the turning point. So if I take the derivative of my expression, the expression being minus x cubed plus ax squared plus bx now take the derivative of that. What do we end up with? Let's just go back there and make sure that we've got our values down correct. Yep. The derivative would be negative 3x squared plus 2ax plus b is equal to 0. All right, and we know that the x value at point B is 6, so we substitute the x in and we end up with minus 3 minus 3 into 6 squared plus 2 times 6a plus b is equal to 0. All right, so we are going to need to simplify this one a little bit further. So we can get equation 2, and we can use equation 2 together with equation 1 to help us find the values of a and b and show that a is 12 and b is equal to negative 36. So let's quickly do that. We've got 36 times negative 3. Let's have a look at what we get there. We've got minus 108. So we've got minus 108 plus, let's just go back to our slide, plus 12a plus b equal to 0. All right, and what I'm going to do is I'm going to leave you with this. So this is equation 2, and remember what we've got? We've got equation 1. Equation 1 we worked out to be 36 minus 6a. That's the value we got for b. We're going to take that, substitute that into equation 2, and you should get that a is equal to 12 and b is equal to negative 36. I'm going to leave that for you to simplify, and we're going to get back after this quick break. Alright guys, remember we are back from a break and you had a bit of homework because you needed to check those simultaneous equations and make sure that you can solve them and you can show what the value of a is and what the value of b is. A had to be 12 and b had to be negative 36. So let's move on with this same question. We are calculating the coordinates of a being your turning point. We've now got our equation of h of x. In order to find our turning points, by now you know we need to find the derivative. So we take the derivative of negative x cubed plus 12x squared minus 36x. We get negative 3x squared plus 24x minus 36. Divide through by a common factor of minus 3, and you get x squared minus 8x plus 12. You then have to factorize that further. So it becomes x minus 6 times x minus 2 is equal to 0. We get x is equal to 6, which is good because we already know that the turning point, the x value at the turning point B was 6. And you get x is equal to 2. So the x coordinate at point A is 2. But they asked us to find the coordinates, which means we also need to work out the y value. To do that, we take this x value of 2, we substitute it back into h of x. So h of 2 will be equal to negative 2 cubed plus 12 times 2 squared, right? Minus 36 times 2. Now, in an exam, guys, you don't have to waste time rewriting all of this and saying it's minus 8 plus 12 times 4. Put it straight into your calculator and see what you get. All right. So we're going to say minus 2 cubed is 8, so it's minus 8 plus 12. 2 squared is 4. 12 times 4 is 48. Of course, you can write it exactly like that. Minus 36 times 2 is 72. And your answer here is negative 32. So therefore the coordinates of A are 2 and negative 32. Okay, so far, hope you're doing well. We've got our turning point at point A. We now need to move on to the next question, which says calculate the value of y. Y being the corresponding coordinates or the y value that corresponds with an x value of 3, which is a point on the graph. To answer this, we need the equation of our graph. So let's just remind ourselves what that was again. It was minus x cubed plus 12x squared minus 36x. Okay, we know that the x value is 3, so we're simply working out a function value here. This is marks up for JAM. It's really just simply a matter of calculator work. You don't have to do anything besides show the substitution and then use your calculator to work out the function value. Okay, let's quickly do that. So we're going to get minus 27 plus 12 times 3 squared minus 36 times 3. And that gives us negative 27. So therefore the value y is equal to negative 27. If you get a question like this, you're really lucky. This is marks up for JAM. It's just testing that you know how to substitute values in. All right? Okay. In this question, they say, is the graph of h concave up or concave down at point T? Now remember, whenever we're talking about concavity, we are talking about the second derivative. Okay. Is the graph concave up or concave down? If your second derivative is positive, then your graph is concave up. If your second derivative is negative, your graph will be concave down. So we need to call again on our equation. We just need the equation of the derivative, but we'll use h of x again. Let's write it down. It's minus x cubed plus 12x squared minus 36x. All right. We take the derivative of that. And remember, we're not interested in the derivative. We're interested in the second derivative. All right, we go one step further. Let's work out our second derivative. And what we're interested after that in is the sign when we substitute the value of 3 in. So we get minus 6x plus 24 as our second derivative. We take the value 3, substitute it into this equation. All right, and let's see what we get. So we get minus 6 times 3 plus 24. Minus 6 times 3, that's negative 18 plus 24, which is 6. 24 minus 18, we've got 6. All right, so we see that the second derivative at that point is positive. Okay, so the second derivative at 3 is positive. So therefore, if your second derivative is positive, it means that your graph is concave up. So therefore, at that point T, your graph will be concave up. Okay, and let's have a look at the final part of this question. Determine the coordinates of the point of inflection. Well, we've almost done all the work. We already worked out the second derivative in this question. We've got minus 6x plus 24. Remember, your point of inflection is at the point where your second derivative is equal to 0. So it's now simply finding x, divide through by negative 6, so you get x is equal to negative 24 divided by negative 6, which is 4. So therefore, the point of inflection here was x is equal to 4, which is just above that point T. All right. And so that means at that point T, your concavity is going to change. Now, we saw that when x was at 3, the graph was concave up. So if 4 is now your point of inflection, what it means is as the graph continues past the value of 4, your graph is going to change its curvature. So it's going to become concave down. All right, so those are some key concepts and some key skills that you've learned in this question. We looked at points of inflection, we looked at how that affects our curvature, and we also looked at how we can solve simultaneously to find unknown values. I think with that, guys, let's take a break. We're back after this. Well, thank you all for joining us in this lesson on cubic functions. We're about to wrap it all up, and let's see what we talked about today. We looked at finding the equations, and we looked at interpreting graphs. And importantly, we looked at some of the keywords, some of the language we use when we talk about graph interpretation. And when we look at finding the equations, we looked at the fact that stationary points mean the same as turning points. And we did discuss quite a bit about points of inflections, second derivatives, and concavity, and how the concavity changes, and how we can use the sign of the second derivative to help us work out the concavity. We discussed some of the incorrect methods for finding the equation. Well, we use the correct methods, and remembering that there's not one method that you can use all the time to find the equation of a cubic function. We didn't want to use incorrect methods. We use correct methods, and we do that by reading the question correctly. Okay. Important time management skills are incredibly important. Reading the question carefully, incredibly important when you are answering your exam questions. Making a note of key information, and often even making a little sketch can help you to just see things a little bit different. Sometimes it's easier to visualize than to just read the writing all the time. So make sure you do lots and lots of exam past papers, because exam past papers is where you're going to get the experience. Experience is important. Before you write your exam, you need to be experienced by doing lots of further exam questions. Here are a few of the exam questions that you can practice when you've got time by yourself. Try and time these so that you're working to roughly a mark a minute, and you're sure to be successful when you sit down to write those exams. All right, guys, that's it for today. Cheers.